Thanks. Well, hello, everybody, and welcome to this session. First of all, thank you for the invitation and the opportunity to present and share with all of you. I love to do this. I love to go and have reach to different user groups, different, meetups, and all those kind of things. Definitely one of the not so many benefit of this 2 years pandemic time was, for us, the speaker, to be able to reach different communities. In my case, during last year, I was able to reach all 5 continents with the multiple sessions all around the world, all around the clock. So that's one of the few good things of 2020 and 2021. Anyway, let's start with this session. The name is Performance Features in SQL Server and Azure SQL. A little bit about myself, just as a quick introduction. My name is Javier Villegas. I am from Buenos Aires, Argentina. I work at Mediterranean Shipping Company as an IT director in the DBA and BI Services area. I've been working with SQL Server for over 25 years now. I am Microsoft MVP in the data platform category since 2016. I'm also Microsoft certified trainer. I am member of the board of advisors for the Azure Data Tech community. This group of community that is run by the community and empowered by Microsoft. Well, all these groups, after PASS explode a couple of years ago, we're trying to, help the multiple communities, the data communities on this new journey. I'm also defined myself as a technical speaker. I've been part of a bunch of events and conferences, as I mentioned before. You can also find my contact information, email address, Twitter, LinkedIn, my blog, in case you want to get in touch with me to discuss about this presentation or anything else you would like, or eventually if you just want to do networking. I'm also one of the leaders of our local SQL Argentina group. We've been running the monthly meetings, mainly in Spanish. I don't know. I mean, I still hear the echo so loud. So, Matt, I don't know if you can just mute yourself. Maybe that's.
Yeah, if everybody can just mute unless you have a question along the way, you can. I was going to mention that you can type it in the chat as well, and I can relay it along too. So, but if everybody could just mute for now, then that would be great.
And if you want to stop me for questions or anything at any time, is fine. So, performance features in SQL Server and Azure SQL. Let's start. First of all, let's define a little bit what is this new Azure SQL thing, something quite new. We all been working with SQL Server for multiple years, different versions, doing, a bunch of creative things. But now, since several years ago now, we have this new umbrella called Azure SQL. So let's see a little bit what it is, what it has to do with SQL Server, what is the relationship, and then let's gonna dive deeper into the performance features, which, by the way, they work in every single version of SQL Server and Azure SQL that we will be presenting today. Also, if we focus a little bit on SQL Server per se, the product, right? We have multiple SQL Server versions since SQL Server 6.0, which was the very first one I started working with. until the most recent one, SQL Server 2019. Each of the latest version was introducing a new set of features related to cloud focus, high availability, multi-platform, BI, etc. What I would like to mention at this point is that Microsoft calls the modern version of SQL servers the ones that are 2016, 17, and 19, right? Those are the ones that Microsoft called modern SQL Server versions. So this session, the features that we will be covering are based on these versions onward. I'm gonna emphasize on each of the version eventually if we had to do, a focus on each of them. So as for today, we have this Azure SQL thing. So what it is really? First of all, you know that Azure is the Microsoft cloud that help users, developers, enterprises, companies to deploy their infrastructure, their services into the cloud, right? So SQL Server, or the, let's say, data platform area, is one of the bigger pillars within the Azure network. So if we focus on Azure SQL for a moment, let's see what we can find in Azure. First of all, we have SQL Server running on Azure virtual machines. These are virtual machines, the one that you may have for something else eventually, right? But in this case, running SQL Server. Which SQL Server version? Well, we will see that we're going to be able to install any kind of SQL Server version and edition, and eventually on multiple platforms, right? We can install SQL Server 2008 R2 eventually if we have to. What is the benefit of having SQL Server running on this virtual machine is that when you deploy one of these through the Azure Marketplace, you have the possibility of doing this setup of SQL Server, right? But just covering many of the best practices that Microsoft has in all their documentation, right? At the moment that you deploy the virtual machine. So you go there, you create your virtual machine, and all that stuff that we all been doing for our SQL Server, like, configuring the storage, configuring the service account, putting the TempDB in a separate drive, etc., etc., etc. Most of them are already coming when we deploy one of these virtual machines. On the same side of the history, these virtual machines, Microsoft called this infrastructure as a service. And why is that? Well, basically, it's just a virtual machine, as I said. So below SQL Server, we have an operating system. We have to set up the authentication with the Active Directory. Eventually, we need to set up high availability and disaster recovery. We have to take care ourselves of doing all that. Eventually, if we need to apply Windows patches, we have to take care of it. So this is why Microsoft call it infrastructure as a service, right? It's very easy to set up one of these, but there are a lot of, let's say, administrative tasks that we have to take care of. So this is infrastructure as a service. Then, on the other hand, what Microsoft called platform as a service, there are two flavors of a SQL-like service, right? And what is that? Well, these two are Azure SQL Managed Instance, right? And Azure SQL Database. What is this platform as a service means? Well, basically, Microsoft is providing to us a SQL Server-like endpoint. So we connect with our Management Studio, Visual Studio, Azure Data Studio, our application to an endpoint, and that's it. We have SQL. We don't know / we don't care what is behind that? Because Microsoft is providing and supporting, maintaining and administering the infrastructure behind these two services. Right? That means that we don't need to take care of high availability and disaster recovery. We don't need to take care of the patching because, again, this platform as a service is only SQL or these versions of SQL Server for us, right? And we don't care about the platform behind. And why we have two of them, Azure SQL Database and Azure SQL Managed System? Well, first of all, I mean, each of them has its own purpose. Managed instance is basically, the managed service of SQL servers. It's not exactly SQL Server. It's almost 100% compatible with what we know for SQL Server, right? Again, as a service, we can deploy multiple databases on it. We can easily do a migration from our on-premise SQL Server, taking a backup and restoring it to managed instance. We can have, our legacy application also running against managed instance with minimum effort, right? On the other hand, Azure SQL Database is this new platform. Well, actually, it's not new. It's one of the very first services in Azure, but it has evolved a lot, right? In where we have a unified database in where we can do all our deployment in only one user database. What does it mean? If we have an application that, for example, has a database which has a store procedure or a view or something which has a join with the tables on multiple user databases, well, we cannot do it in Azure SQL Database, again, because all the options need to be on the same user database, right? For that case, we need to choose managed instance. But Microsoft provides us with a rich set of tooling and assessment to do migration from SQL Server on-prem, from virtual machine to any of these other services with, some effort in some cases, but in some others it's not too hard. It's just backup and restore, right? So this is Azure SQL, the SQL Server that we know, running on virtual machines, managed instance, and Azure SQL Database, right? So the interesting thing is that nowadays SQL Server runs almost everywhere, right? And why I say that? Well, first of all, we can have our bare metal servers running in our data center. We can have VMware with multiple virtual machines running SQL Server any version. You also know that since SQL Server 2017, Microsoft gave us the possibility of running SQL not only in Windows servers, but also under the most important Linux distributions like Ubuntu, SUSE, or Red Hat, right? So we have a choice of the platform at this point. Also, since SQL Server 2017, we have the possibility of running SQL Server in containers, like, for example, Docker. Eventually, if we need to orchestrate those containers to build a big solution, which may involve a production environment with high availability, disaster recovery, we can have those containers running at the top of Kubernetes, right? So SQL Server may run on this with no problem. And as we said before, SQL Server, virtual machines, managed instance, Azure SQL Database, and recently Microsoft added into the Azure SQL family the SQL Edge, which give us the possibility of running a SQL Server engine on an ARM device, like, for example, Raspberry Pi, right? So we can have SQL Server running on a Raspberry Pi or any other ARM device. Of course, we won't be running our business critical workload on it, but for certain scenarios for Edge, it makes a lot of sense, right? So Finally, just to close this Azure SQL introduction in few words, the platform as a service option has a lot of benefit. As I said, we don't have to take care much about the infrastructure behind. So whatever is related to high availability disaster recovery is coming as part of the service. We don't need to take care of the backup because there is an automated backup system that works underneath, right? So again, this is something else that we don't need to worry about. Eventually, we need to configure long-term backup retention. We can do it very easily through the Azure portal. And also, if we are trying to certify for any, certification like ISO or something like that, which they ask you to have your backup stored in multiple locations, remote locations, etc. You can do it through geo-replication, so your backup can be replicated into multiple places at the same time. Also, and this is not only for platform as a service, it's also for the virtual machines, you have the possibility of doing scaling very easily. What does it mean? So if you click through the Azure portal, you can assign more CPU, more memory, faster disk to all these virtual machines, and just reboot, and boom, you have the new hardware or the new set of CPU and memory over there with absolutely no problem. Of course, there is a cost implied, right? You have to pay for that. But scaling for any of the Azure SQL services, and also most of the Azure services, not only related to SQL or data platform, the scalability option is really easy. Also a lot of emphasis on security, right? The advanced security is not only at network level, at virtual machine level, but also at SQL level, right? With advanced threat protection or Windows Defender that you can have on your services as well. Something important for the platform as a service offering managed instance and Azure SQL database is that it is versionless. Remember that before we just said that we have SQL Server since 2008, for example, and every couple of years there is a new major release. For that, we, the DBA, we have to plan the upgrades, test, validate all the applications, etc., and then do the upgrade migration. Well, in platform as a service, we have this concept of versionless. This is just Azure SQL. There is no version tied to it, right? So today, in 5 years, or in the future, it's gonna be Azure SQL, period. No version for that. Does it mean that Microsoft have this static, is not doing any improvement? Absolutely not. It's actually the other way around. They put the new features on Azure SQL Database and Managed Instance first, and then they move it to the SQL Server next release or any cumulative update or something like that. So this is the concept of versionless. Built-in monitoring, you can have all the tooling that we've been using to monitor SQL Server since forever, profiler, extended event, you name it. And also the benefit of the Azure cloud, that you can have log analytics and do advanced monitoring for your Azure SQL environment. And then the built-in intelligence, right? And this is the part that we're going to start talking right now, because this is what, the benefit for the performance feature, right? So historically, if we need to talk about performance, we have a set of pillars that we have to consider, right? Memory, CPU, I/O. Right? These are the three most important things that we have to consider when we are building a new environment, doing the architectural part of our application, consider, the amount of CPU, how we're going to distribute the file through the different disks, how we're going to configure the storage, etc., etc. So, and if there is a performance problem in our environment, well, most probably is one or more of these three things that we just mentioned. There are other problems historically that we as a DBA, we normally see, like, for example, this case in where, we have this very, very important report that runs in the middle of the night, normally takes half an hour to complete. And one day we get into the office early in the morning and we take our coffee. And when we're about to start the day, we get this phone call saying, hey, this very important report is still running. What's going on? When we go check, nobody made any change. Nobody, had modified anything. This report is just taking forever with no explanation. Well, actually, there is an explanation, which is most probably an issue with the execution plan. If we don't do the updated statistic, if we don't do our maintenance, or if just SQL take the wrong new plan, well, most probably we may see the problem that I just mentioned. So what are some of the intentions of these new features? Well, I believe that besides trying to improve the performance and make our existing workload faster with minimum to zero code change, also the idea is to try to stabilize the performance at all costs. Doesn't matter if the server is idle, doesn't matter if the server is really busy, doesn't matter if there is a planned regression or something like that, the performance is stable all the time. So we will try to understand a little bit how to accomplish all this. So if we talk about monitoring and troubleshooting, we all know what we need to focus on, right? We, as I said, CPU, memory, and disk. But we also have dynamic management views and functions, which allow us to, or SQL give us all it, performance metric through it, and we can just jump into it and understand what's going on, and with that information, try to start our troubleshooting process. And then let's enumerate all the features that are really, really important for SQL Server and Azure SQL. First of all, and more important, is Querystore. Querystore was first introduced in SQL Server 2016, right? We're going to go through all these features in a minute. Then, after that, in SQL Server 2017, Microsoft introduced automatic query tuning. We will check it in a minute also. Also, in 2017, started this new concept of adaptive query processing that then in 2019 was not only renamed, was changed for something a little bit better and with more, capabilities, which is intelligent query processing, right? Also, the possibility of having column store and in-memory OLTP help us a lot in terms of performance. And then exclusively on SQL Server 2019, there were some changes for, or improvement at 10 dB level that, make our workload to run much, much faster, again, with no code change, right? Here, I'm just mentioning these features that we're going to be covering, and they work on this SQL Server versions and also in Azure SQL, right? So let's start a little bit understanding this concept of intelligent database. Well, we as DBA, we just, stay there with our monitoring tools, just doing troubleshooting, seeing if one of these execution plan go nuts, if the CPU usage go to the roof, if the disks are not behaving well, if we are missing an index and we need to, tune the code, etc. Well, some of these things can be done with this new concept of intelligent database. This is a process that basically helps us to capture everything that is happening within our database, right? And then take some choices with that information that is captured. And with that, we're going to start with Querystore. So Querystore is, as I said before, was released with SQL Server 2016, an important, milestone and really great feature, which actually is the basis of most of the other features that I will be presenting today, and also for features that are coming in the next SQL Server version. We're going to mention that also later. So what is this Querystore? Well, I like to define it like the flight recorder of our user databases. Right? So when we have Querystore enabled in our user databases, what is happening there is that SQL is storing within the user database all the plans for every single procedure, ad hoc query, or every single session that is running against our user database. And if there is a change on that plan, it also saves the new plan. At the same time, it's also storing all the runtime information, like, for example, how many times it was executed, for how long it ran as minimum, maximum, average, the amount of reads, writes, etc. In 2017, they also added the possibility also to capture weight stat information through Querystore. So this is something that when we enable it, it's just doing all the things that I said, capturing execution plans and capturing runtime information. So what can we do with all this? Well, we will see that there is a really nice dashboard which is going to allow us to get certain reports, which, for example, the processes that are taking, the top 25 processes that are taking the longest, right? So we can go identify those processes. We can see the runtime information for those, for example, procedures, and we can see if there was a problem with the execution plan, if there was a plan regression, etc., etc. So we have all this information in front of us. We can see all the processes with the regressions. And again, knowing this information is going to be easy for us to do troubleshooting. One important thing introduced also with Querystore is that eventually, if we identify one of these procedures that had a regression in its execution plan, we can manually force the execution plan for that procedure to be used, to use one that was better from before, right? So we decide, hey, this plan that is using right now is not as good as the previous one because it's using more resources, more duration, more CPU, etc. So then manually we just go and say, hey, use this plan, and we will force the execution to use that particular plan so we can set, the basis in terms of performance. This is huge, right? Because again, we won't have that problem with the variation for the execution plan, the duration, etc., because we will manually, set the plan for the one that we identify as regression. So how all these things work? Well, you know that when SQL Server is running code, the first thing that it does is compile and get with a plan, right? That plan, can go to the cache, but it also get stored asynchronously into the Querystore schema. So, when it get the compilation, when the plan is generated, it also goes to the Querystore repository. Then SQL execute that code based on the plan that was compiled in the previous step, right? And when it runs, we're going to have runtime information like, duration, resource usage, etc., etc. So that information is also stored. And then we will see all these interesting reports, and it's going to help us to take decisions. So something important to mention is that, again, since SQL Server 2016, we have Querystore, and it is in SQL Server is disabled by default, right? So when we create a new database, when we restore a database, Querystore is disabled. So if we want to have this feature, we just need to go there and enable it, right? It's quite simple. If we go to the database properties, we can do it from there with no problem. So again, this is a summary of the things that we can have with Querystore. So then from Management Studio, we can, if we have Querystore enabled for that particular user database, consider that I'm saying user database. So if you have an instance with 10 databases, you have to enable Querystore in all the databases manually, right? Or you can, if you want, you can enable it in just 1, 2, 3, or all of them. But this is something that you have to do, right? So then from Management Studio, you will have this set of reports, right? And you will be able to see the top resource consuming queries, the queries with, force plan, or the query with regression, right? So then we will see how to do it from the user interface, but also using this store procedure, right? SP, Querystore, force plan, or unforce plan. We can, make the plans to be forced for a specific query ID. Well, here we also have a set of best practices for Querystore, really interesting to read, and this is something that Microsoft came, eventually if you have a very busy environment, highly transactional, etc. Well, there are some trade flags that you may need to enable for those. Otherwise, if it is a normal environment, just enabling Querystore is really easy. So, well, really nice feature. I love it. I use it a lot. But, if we have the problem that I mentioned at the beginning, this report that gets done in the middle of the night, right? In order to be able to fix the problem, there should be someone in front of the Querystore panel, right? Identifying the query and doing the manual force. But, if we arrive at 8 a.m., we have this whole regression during all night until we find the regression and we manually set the plan, right? And to address that particular problem, Microsoft in SQL Server 2017 added at the top of Querystore automatic query tuning, right? What can we do with automatic query tuning? Well, if you have your user database, you have Querystore enabled, and you also enable automatic query tuning, if SQL Server, if the engine detects that there is a regression in any of the queries running on your server, it will automatically, right, fix the problem by forcing the last known good plan, right? That means that, if we have in our report scenario, right? If the problem happened at 3 a.m. in the morning, it's gonna detect the regression right away, and it will fix it right away. So we don't have to wait until someone take any manual action, right? So this is automatic query tuning. Really, really easy to enable. Again, Querystore has to be enabled as well, and starting SQL Server 2017. So how this process work? Well, basically is constantly capturing through Querystore. This is the learning part, adapting the code by manually fixing the execution plan, setting the execution plan to the last known good one, and verifying that the new plan or the execution is improved, right? And this keep moving constantly. If eventually there is any other change in the future, right, it's gonna be adjusted the same way. So how do we see this plan regression situation? We have this report, for example, that it has the plan 1, then it changed to plan 2, plan 3, and eventually the plan 4, because when SQL Server come up with the execution plan, it's trying to get the best plan in the least amount of time. That doesn't mean that is the best of all the plans, right? So it's doing its best effort to come up with a really good plan, but not all the times happen. So this is when we see this regression. So what automatic query tuning does, if it detects the regression, right? Again, it will manually set it to the last known good plan, right? This is really interesting. I use it in most of our environment. So if you are not familiar with it, I definitely would like you to give it a try to both Querystore and automatic query tuning. With that, we are doing this zero code change and try to have our environment quite stable. Doesn't matter what's happening on it, right? And again, I, at no point in my presentation I told you you had to go and modify your store procedure and add this hint or anything, right? It's just happening when these features are enabled. That is quite interesting as well, which is, as for today, only applying in Azure SQL Database, which is automatic index management, right? Having Azure SQL Database and enabling this feature, what we will see is that beside the Querystore information, which by the way, it comes enabled by default in Azure SQL when you create a brand new database, right? You can have this automatic index management. So if SQL Server detects that in the code running against the database, there is an index that could be created to improve the performance for this particular session, report, store procedure, etc., it will create an index on the fly, right? So I said correctly, right? It will create that index for you, so you don't have to worry about. And eventually, if that index is not longer needed, it could drop it automatically, right? So this is quite interesting. I'm coming from an old school, so I don't like anybody to create and drop indexes in production all the time. I can tell you that when I tried and all the information that you can read online is quite safe, but again like everything else, it needs to be tested properly, right? But if you want, you have the possibility of this index creation and dropping on the fly, beside the plan forcing, right?
So hey, let me ask you a quick question, if you don't mind. So I know how I feel about the database tuning advisor, and I wouldn't just take its recommendations, right? Just put them in. So this is similar, right?
No.
Okay.
The automatic tuning, I don't even recall the name because I used it on my very first day of at MSc, and I made a mess with that, and right after I never use it. What you have in automatic index advisor or whatever the name is that it will create the indexes for you, right? All of them, and then it will start dropping them. In this case, it will just check, like when you get the missing index report, if the workload that you run is coming up that, well, every single execution, it is asking me for this missing index, and this missing index will have like an important weight. If we create it, it will create that one.
Right. Okay.
Not,
okay. Okay. Yeah, I never turn it on because I'm a little nervous about it adding its own indexes, and suddenly I've got 10 indexes and I don't want that many, or I don't know how it works.
Yeah. Again, never use it in a big workload or let's say critical application, but I have it enabled in some of the environments, and it works quite well. Let me tell you that what I normally do, I have it in most of the lower environment, not production, not pre-production, but I try to come up with the report of all the indexes that it creates. And eventually, if I can verify that the index that was applied and created got some advantage in the workload, again, not in production environment, eventually, I consider the index to be created manually in production. Right?
Yeah, okay. Yeah, that's how I would do it too.
Yeah.
I agree. So I think we have another question too. Oh, sorry, go ahead. I think we might have another question. Eskin raised his hand. Can you unmute, or do I have to? Okay.
Yeah.
Okay.
Yeah, no, it's actually along the same lines there. I agree. I don't really like taking the query tuners just recommended indexes right off the bat, because what I found is it doesn't take into account your existing indexes. I'm curious if there was any advances in that where the behavior of what it's recommending actually takes into account indexes you already have, and would maybe, drop one index and recreate it slightly differently to include another field or something like that, or if that's really something you still need to keep an eye out for is indexes that would be good to have, but kind of clash or would be unnecessary or render one of your existing indexes unnecessary, causing you to have to manually go in and, okay, this one replaced this one, I'll drop that. Has there been any advances in that, or is that still kind of the case?
No, basically, it's going to come up with recommendation that eventually may include the same indexes that you have, but with an additional column, right?
Right.
It's not going to take the existing one, drop it, and create the one, right? So again, I like to mention it again. It's nice. It's really good in terms of execution or resource usage. It's really, really good, right? But as you guys said, I don't want anyone to be messing up with indexes in my production environment at any time, right? But again, if you go online and check, a bunch of users have it in production environment, mainly with no problem. I know that there are some tunings that allow you to configure just not to create or drop the index on peak hours or when the system is busy or something like that, not to add additional noise, etc. But again, it's worth to mention it. It's worth to know that it's there. It's worth to give it a try, but it's at your own risk, let's say.
I like that, at your own risk. It should be a warning on there, at your own risk.
Yeah, I believe there is. I believe there is. Probably with the
Like
small
really
letters.
tiny white font on a white background.
Yeah. But again, I like the possibility of having it there. It's like, an additional layer that maybe could be useful for new DBAs, right? Or if you are new, with that particular environment or something like that, you can consider it. Again, you can eventually have the situation that I have with automatic index advisor 16 years ago, messing up with production environment right away. But I believe it got quite good. But again, it's exclusively for Azure SQL database. It's the only, Azure SQL service in where you can have this enabled. The index part, the one for the plans, right, is for every single component within the Azure SQL family. So, any other question? No? Okay.
I think we're good right now.
Great.
Javier, I've got a question for you.
Oh.
Yeah.
Can you give us any more tips and tricks about forcing execution plans?
I guess you will have your answers when you see the demo in a few minutes, right? There are a bunch of graphical tools to see those recommendations, but also T-SQL code that is accessing dynamic management views and functions to get all those recommendations and actually see when, adaptive query processing with automatic query tuning, when it forced a plan, which was the gain of having this plan forced versus how it was before. So there is a ratio of, you gain this amount. I mean, it's not giving you a percentage of something like that, but it's giving you a number to get a rough idea of the improvement that you have by having the feature enabled and by forcing this particular plan, right? We will see it in a minute. But again, the most important part, as you remember my example at the beginning of this important report, right, is you can be at your home watching a movie, and if there is a regression, nobody needs to be in front of a computer to manually force the plan. It will do it automatically for you. And let me tell you, this is what I actually do, right? It's not like the index thing that I mentioned before. I do rely 100% in Querystore with automatic query tuning, right? Because it just works, and it works really well. We will see it in a few minutes. So then, also in SQL Server 2017, Microsoft has introduced this other concept called adaptive query processing. And this is quite interesting, actually. You know that when SQL Server runs a T-SQL code for the very first time, as we said, it's going to compile the plan, and it's going to have it into the cache, and we'll reuse it the following execution. Until now, that plan was static, right? That means that it gets compiled, it gets the plan, and it's going to be using it this way for more execution until it gets with another one. But if that plan has some problems, like, for example, memory grants, doesn't matter. It's going to use it no matter what, and it will hurt other executions if that's the case. For example, for that case regarding to memory grant, let's say that SQL runs a query, it compiles, and in the compilation, it is saying, okay, for execute this query, the plan is granting you 10 megabytes. All right, so nice. I'm going to have 10 megabytes allocated for that execution. So then I execute the same query, maybe with a different parameter or something like that. But in reality, instead of using these 10 megabytes that were granted when the plan was compiled, it is using only 1 megabyte, right? So you are wasting 9 megabytes. You can tell me, well, I have a server with plenty of memory, 9 megabyte is not a problem. But what about if that store procedure is being executed 500 times per minute, right? You're going to be allocating a lot of memory, and then you're going to be using 10%. So that you will have impact not only on that execution, but also on the overall instance, right? And what about the other way around? So it allocates 10 megabytes, but at the execution, it end up using 30 megabytes. So what's going to happen? SQL Server will execute it anyway. But for the memory that the plan does not allocate, is going to be using 10 dB to spill to disk and get that extra memory. And guess what's going to happen? It's going to run like hell, right? Because we all know that when it uses 10 dB, it's not, very nice. So again, this plan was static. So with this concept of automatic query processing, what Microsoft is doing is, okay, I get the initial plan, I get certain amount of memory, and then I execute it. If the plan notes that, it's using less memory, it will adjust the memory grant for the following execution. And in the other case, if it ends up using more memory, it will also allocate more memory in the following execution. And you have to do nothing with that. We will see it in action in a few minutes. You will see that is really, really great. We are good with the timing, right? I believe we are. Still have half an hour ahead.
Yeah, we still have more time. Yeah, it's only 6:30 here, so you can, it's getting late for you, I think, though. So I appreciate you. Keep going, but thank you.
It's fine, it's fine. So
okay.
This is adaptive query processing in SQL Server 2017. So it's not only for this case of, memory grants. There are also other cases, like, for example, as I said, memory grant feedback, but also, this concept of adaptive join. This is really nice because, again, when you have a query that basically involves multiple tables and it's doing a join, it's going to come up with the execution plan, and within the execution plan, it will decide a type of join, right? But then eventually, in following executions, when you join the table, it could come up, the join can come up with, few rows, or it can come up with thousands of rows. And, in the plan, it is, it was chosen one specific type of join. Well, the adaptive join option, it will allow SQL within the same plan to choose between two options depending on the amount of rows on these joins. Again, we will see it. It's really, really interesting. So this was, as I said, first introduced in SQL Server 2017. Then in 2019, Microsoft expand this concept of adapting query processing and call it intelligent query processing, also adding few other things, right? As you see in the slide here, in the boxes in where the letters are normal, those are the original one coming from 2017, and the one in bold are the new ones in 2019, right? There are a bunch of more situations in where the plan get this feedback after being executed and adjust itself for the upcoming execution, right? Let's give you a much better way to, stabilize the resource consumption, and to have, again, what we said at the beginning, and stable execution along the way, right? The one that I like a lot here is scalar UDF inlining. You know that historically SQL Server is not doing very well with scalar function. Just to refresh a little bit, this scalar function are this piece of T-SQL code in where you can put a bunch of logic, business logic, and then you use that function to return a scalar value, and you can use it, at any part of your query, in the select or, in the predicate if you want. The funny thing is that the SQL engine consider that this scalar function has almost no weight, so it's kind of free to execute it. But in reality, it is not, and it's quite the opposite, right? I've seen a bunch of systems going to 100% CPU because of a developer creating a really interesting scalar UDF being used in the predicate, right? And when you go check, you see where is the problem, and it was also hard to identify because SQL Server is always assigning a fixed weight to the scalar function. Now, with intelligent query processing, what the engine does, it compiles the guts of the scalar function and then embed it into the main plan, and is much better, and you don't have this problem that I mentioned before. I remember when I first read about this scalar UDF inlining in intelligent query processing. I read it in a magazine several years ago, and it was the header was or the title was, Microsoft has fixed a bug from 20 years ago, right? In reality, it was not a bug, or maybe it was, I don't know. But, now with this feature, it got addressed finally. So really, really nice. So how do we use all those beauties of adaptive query processing, intelligent query processing, etc.? It's really, really simple. We just need to go to our user database and change the DB compatibility level, right? We can have 140 for 2017 or 150 for 2019. And we will have all these features enabled in our user database. And again, if you see, you don't have to do any code change. So you don't need to modify your code at all. Then another beauty, something that is extremely useful, is this new feature coming in SQL Server 2019 called lightweight query profiling. What is this lightweight query profiling? So when you're running, this famous report of my initial example, right? And you get the phone call, your manager can ask you, at which part of the execution the report is at the beginning, is at the middle of the execution, or it is about to finish. You have absolutely no idea at which execution point you are. With this feature, with lightweight query profiling, for every single query running against your instance, you can see the estimated query progress between 0% and 100%. You can see, right, at which point of the execution you are. It's an estimate, of course, but it's much better than being blind and not knowing where you are. So really, really, really nice. We will see it in action in a minute. So as I said, this is coming in SQL Server 2019. It is enabled by default. So a beauty that Microsoft did for this specific feature is also ported to SQL Server 2016 and 17, right? It is not enabled by default, just not to break the compatibility, etc. But if you enable a trace flag 7412, you can also have the estimated query progress for your queries. Really simple. So we will see in a minute, and you will love it as I do. And then, for 10dB, historically, tuning 10dB is quite hard because, we have to set up the specific storage. We have to put multiple files depending on the amount of cores, etc., etc. Well, we still need to do that. But, in SQL Server 2019, Microsoft has introduced, you remember this technology called Hackathon, which is in memory, right? That, it's like moving your user tables to memory, so there are no latches when you access those tables. Well, this one is for certain type of data. Actually, your tables metadata, it won't use the disk, so it's gonna use the memory, right? So there's not gonna be latch on dropping and creating object. We will see it also in a few minutes. Again, zero code chain, you just enable this feature and you will see that for certain workload is much better. So let's see all this in action. So here I have my virtual machine running SQL Server 2019. I believe I also have Azure SQL database here. Let me see, because I haven't enabled Summit. As you can see, I have a SQL Server here with the, one type of icon, and then the Azure SQL database with a different one. So just for you to see that they are a little bit different one of the other. I don't have a managed instance created right now, which has a different icon, but just for you to see it. So let's start with lightweight query profiling. So again, I have my Management Studio, my query. I will enable here, include live query statistics, right? So I will do it here, and then I will execute my query. When we get the query down here, see that at the top, we have estimated query progress. And, we see the plan moving, right? We see it up there and also down here. We are at the 20% of the execution, and this is gonna keep running. So let me cancel this one, run the second example, and, here you will see it better. This one is progressing. You see 10%, 12%. So this is moving, right? So you see at which point of the execution you are at. So really useful. There is minimum impact in the CPU usage, or the instance is really, again, it's enabled by default. So now you can come up to me and tell me, okay, this feature is really nice, but I'm not running my, code through Management Studio. I'm using my application, my web server, my middle tier to run the code. So I cannot see the progress over there. Well, it's not like this. If you go to your SQL Server instance and you check the activity monitor, you can see the progress of all the queries running against your server. So here I will execute, where is my, where is it? 1 second, it's my batch. Okay, this one is just doing random workload on my user instance. It is there. So with the activity monitor, It's going to take a little bit to populate, you know, all the processes running, resource usage. Down here, I have expensive queries, right? So I will expand this one. So here I have all the ones that are running right now. So if I go here, do right click and choose show live execution plan, right here, we will see exactly the same that we saw before. We see the execution live and we see the estimated query progress for every single query running against my instance. Really, really nice feature. Okay, so let me cancel this one. So now we will go check Querystore. And for that, I have my demo here. So I started, let me show you what I did here. First of all, I create a database, Querystore demo, right? Then basically I create a table with 3 columns, and then I create a store procedure, which is, you know, doing a select based on the input parameter. And then on this table with 3 columns, I just populate it with a bunch of random data. So if we just go here, I did this before just to gain some time and not waste here with the setup. So here I have a table with just, you know, random data. So this is SQL Server, so I have to enable Querystore manually here. So I will enable it. I just did it. So now what I will do is I will execute the store procedure 20 times. Right? So I execute my store procedure 20 times. So then I go to my database, I go to Querystore, and I will go to top resource consuming queries. This is going to be easy because actually it's the only, let me cancel this one just to not mess it up. It's the only query running against this user database. So I have the query ID number 1, right? With this plan, which is a table scan. Here I have the, you know, the runtime information for that particular execution plan. If I want to see the table here, I see it was executed 20 times with a minimum duration of 2.67 and a maximum duration of 18 something, right? Then I have, you know, when was executed, when was last time executed, etc., etc. So going back to the script, not this one, this one I will move it here. Now I will create a non-cluster index in one of the columns, right? So just create the index, and now I will execute the store procedure again with, I will execute it 25 times. So when I go back to my Querystore panel, I go here, refresh, we'll see that now the query ID 1, which is the same that we executed, is in cache. It now came up with a new plan ID number 2. And if you see it much faster, right? Because, you know, you see it's much faster than the initial one was here at the 70s, and this one is here at the 10th, right? If we go check, you know, this, we see that now it was executed 25 times, and the minimum duration was, and the maximum duration also was way lower than before, right? If we go here, we go and click on each of the plan, and then we will see the shape of each plan. So going back here, I will create another index, right? This time with 2 columns, and I will execute a store procedure again 30 times. I go back to the Querystore panel, I do refresh. We see that again for the query ID number 1, now I have a third plan, right? We see the shape down here, and we see that now the third one is even faster than the other one, right? So again, no code change, we see the execution, right? So eventually, if we would like to say, okay, I want to force to use the plan ID number 2, right? I can do it from here. I just go say here and say force plan, right? So it's asking me for confirmation, and now we will see that we have like a tick in the plan ID number 2, so that means that is false, right? So really, really interesting. So if at the top of this we enable automatic query tuning, it's going to be much better because we won't have to manually force it. So for that, I will show you this guy. Okay, I will show you. I will do an initial setup. Not this one, sorry. Share state. Oh, here. Okay, so basically what I'm doing here, let me also open a performance monitor, and we're gonna come up with one counter. Let's add batch requests per second. So if we go to SQL statistic, we will also come up with batch requests per second. And there is no activity on my instance, so it's nothing. So what I'm gonna do here is I will just run, a random workload again, and we'll see that now we have certain batch requests per second, an average of 70. The current one is around 70, right? So what I will do right now is I will force a regression. I have a code that basically it will enter a regression in our execution. So now you see that the execution, that the batch request that we had around 70s now is around 10, 15, way lower than what it used to be. So here we have a regression. All right. So let me cancel this guy. So now it should go back to no activity. I will set up this again, but the only change that I will add here is that for my database, I will enable, this is not the one. Should be on this one. This is actually the code. So for my database, I will set automatic tuning force last good plan equal on. I will run this, right? I will rerun my report. So again, I have activity here. Let me just clear this. We have around 70s again. I will generate the regression and notice what is going to happen now. I just generate the regression, the batch requests per second drop, right? But then automatically, without me forcing anything, it gets back to how it was before, right? So imagine again, if the regression happened at 3 in the morning, right? It's going to happen this, but then it's going to come back to how it was. And then, for the question that I got before, right? We have the recommendation that is a DMDB tuning recommendation, which is basically when I run here, it's telling me, okay, the query ID 2 with the new plan number 2, right? This was the code that was executed to force it, again, manually. But the beauty here is that average CPU query changed from 88 milliseconds to 450. So it was much, much better, right? And again, you see here, without me doing anything, and here we see the status. It's verifying. I run it again, still verifying, but at the end of the day, you know, we have the same performance, so the regression is not affecting us. So really, really nice. Let's close here and let's go back. Let me also close the Querystore one. And let's go to automatic query tuning. Close some of them so I don't mess it up. Okay. So I want to start with this one. This one is for memory grant feedback, right? Basically, what I'm doing here is just setting the compatibility level to 150 and then cleaning the procedure cache. Then I have a store procedure, right, which is doing a bunch of joins, etc. Right, but I want you to see what's going on. So here I will do all this. Store procedure is created. Now I will enable to include the actual execution plan. And what I will do next is I will execute the store procedure for the very first time with the parameter number 8. What's going to happen here, it's return nothing, right? And when we go check the execution plan, we see here that there is a warning, right? A warning sign. When we go check what this warning is, it's saying at the bottom, query memory grant detected, excessive grant. So it initially granted 67, blah, 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 and it ended up using 800 KB, right? So we are wasting a lot of memory. And you see when here we see the warning sign, well, we have to pay attention. So now we have the plan in cache, right? And what I'm going to do next is I will execute the very same store procedure with a different parameter, in this case, 9, right? So I will execute it, right? This time it will return data, right? It's taking few seconds. It's going to take around 15 seconds, I believe. Yeah. 16 seconds, and it returned 231,000 rows, right? If we go check the execution plan, now we see warning signs everywhere. We have the grant message. We see it here that in the sort message, you know, it has to spill to TempDB, and also here in the join, I also had to use the TempDB as well, all right? Just pay attention to this. It took 16 seconds to return this amount of row. So now let's execute this again with the very same parameter, right? So this time it came back in 1 second, right? Of course, the same amount of rows. You have seen I haven't changed a line of code. I just execute it, right? And when we go check the execution plan, now all the warning signs are gone because it adjusted the memory grant for the execution, right? You see, the very first time, this code took 16 seconds. This one, it took only 1. And if I keep running it, it will take the same amount of time, right? Because it's adjusting the memory grants, you know, for each execution. Really, really, really nice. I love this feature. And again, you have it just having your user database with compatibility level 115, actually 114, because you also have it in 2017 as well. For the adaptive joins here in this demo, I will do the same. I will clean the cache, and then I have just a simple, select statement with a join, right? We see the join here with two tables, orders and stock item. I will enable the actual execution plan, and I will just, sorry, not the actual execution plan, the live execution plan. So when I go here and run this, see that now we have this new operator called adaptive join, right? So depending on the amount of row returned by the join, is going to use one join, one type of join, or the other one, right? So again, with no con change, it doesn't matter, you know, the amount of row that it returns, the plan will adjust to each of the execution. And the one for the scalar function, right? This one is quite interesting. I will create my scalar function. This one is quite simple, actually. This function is based on a customer key. So depending on the key, it's gonna come out with, the category regular, gold, or platinum, considered like a mileage program or something like that. So what I'm gonna do, my first execution is I will set the compatibility level to 130, SQL Server 2016, right? So we put this, I will clean the cache. Again, I will enable the execution plan, and I will run this query, which is actually, passing the customer key, the customer, and calling this function that we just created. If we go here, we execute it, it came back. We check the execution plan, right? And we see that it's quite simple, but in reality, we have this compute scalar, which is the scalar function, right? Which is, estimating an actual the number with 100. This is because, after 2014, it changed the estimated count from 1 to 100. But again, it's not real. So let's see what happened if we change the compatibility level to 150. We clean the cache again, and we run exactly the same select statement, right? When we go here and we check the execution plan, now we see that the plan is way, way bigger than how it was before. And this is because now it is embedding the real plan into the main plan, right? Again, not much to configure, not much to do here. You just put it there and boom, you have it, right? So let me close these guys. And now finally, the changes related to TempDB metadata, right? This is a property that you have to enable for your instance, right? So if you enable it, you just put it there and you have to restart the instance. And if you disable it, again, you do it and then you have to restart the instance. So let's check how this property is set right now. The property name is TempDB metadata memory optimized. Now I got a 0. That means that it is not enabled. And to check that, we will come up with a sample here. That basically what I have here I will do the setup. Basically, what I have here is a store procedure that, as you can see, is creating this, dropping the table birthday if exists, and then create this temporary table, and then doing an insert, and finally doing a showing. So it's dropping and creating this temporary table multiple times. So I just create it. Now, what I will do is that I will call this store procedure multiple times in multiple threads, right? So now it's running. If we go check, we see, you know, the batch request per second that again went to the roof. If we go check the activity on my instance, this is my own version of SP who's active, right? You will see here that there are a lot of blocking, right? The speed 235 is blocking this other. And when we go here and we check the wait type, we see that is page latch exclusive. If I keep running this, you know, we will see that we still have, you know, all these blocks. And this is again because it's waiting to drop and create this table. So we have this problem. It's blocked, right? So it's completely blocked. It's gonna end up eventually, but you know, we have all these blocks. So we can wait till it finishes, but in my case, I will stop it here. I will go back here. I will enable the temp DB metadata on, right? So after I do it, if I check again, it's still showing 0 because I have to restart my instance. So if I go here and I restart the instance quickly, hopefully it come up real quick. It should. Okay, my SQL Server is stopping. It's gonna come up online in a second. Attempt to start. See what I got. If I execute this guy now you can see that the TempDB metadata is enabled. So what I'm gonna do next is, again, I have the store procedure. I won't apply it again, but again, no code changes. I will execute the store procedure again multiple times, right? But now, if I go here to check the execution, you see that there's not gonna be any blocks. It's always executing. There's no blocking, there's no wait. And this is because this dropping and creation of tables on TempDB is not being blocked because the metadata of this TempDB table is now in memory, right? If we go check here, it's gonna take less than half of the execution time because again, there are absolutely no blocking here, right? Yeah, I can keep running this and there's not gonna be any block and soon it's gonna finish. So again, the main concept, without any code change, right? We have performance improvement, great performance improvement, actually. All right. With that, we complete the demo. Here, let me go back to slide. So just to round up, Microsoft has announced last year during Ignite SQL Server 2022, right? It is still in private preview. That is why we cannot just go and demonstrate much. But you know, this is coming hopefully this year, this calendar year. There are multiple new features, really useful. But in the area of performance, they are keeping investing a lot. This intelligent query processing, all those boxes that you saw is going to be much, much bigger with new cases to, have feedback on the execution plan. Something that is really nice to see is that starting 2022, Querystore will be enabled by default, right, on every single new database that you create, right? So this is really, really nice. So here there are some of the changes that they are trying to include in SQL Server 2022 for performance. This, of course, will also have the same effect in Azure SQL Database and Managed Instance as well. And with this, we just finish the presentation. Here I'm having a couple of links in where you can go directly to the documentation for what's new in SQL Server 2019, not only related to performance features, but for all the features. Also here, leaving another link for Azure Fundamentals if you would like to learn more about SQL Server running on virtual machines, on Azure Virtual Machine, Managed Instance, Azure SQL Database. This is the page to start, right? And with that, thank you everybody for your time, for your attention. I don't know if there are further questions about this.
I'm curious about something.
Mm-hmm.
About, so you mentioned Querystore, right? But with Azure SQL, they have that stuff in the portal where they give you performance tuning recommendations like right in the portal, I thought. How does that compare? I haven't used it a lot, so I didn't know. Have you used that at all?
It is actually this. Querystore,
it's actually, oh, okay. I wondered if it was this. Okay.
Query tuning, yes.
Okay. So they're doing that behind the scenes, whether you know it or not.
Correct. Again, remember that when you create a brand new database for Azure SQL Database, Querystore and automatic query tuning will be enabled by default.
Okay, cool.
So you will have this interface through the portal.
Okay, nice. Okay, yeah, I wondered. Okay, yeah, I never use it. I don't know. We set up, we have Azure SQL databases where I work, and then I pretty much, we don't touch them. We don't really have enough time.
That's the beauty, right? Don't touch it. You don't have to, monitor it then much. Yeah. So these are in kind of autopilot, right? Mm-hmm. So again, if you have a mechanism that is forcing and detecting the regression and fixing them on the fly, and not telling you or sending you an email or something, say, hey, you have to rewrite this procedure, include this, blah, blah, blah. You see, I haven't touched any code. That's the beauty, right?
Yeah.
You should enable the feature if you have to. If it is not enabled by default, boom, you get all these benefits.
Yeah, that's nice. I'm gonna have to go back and look. Some of our servers have issues. Well, one of them in particular, our Azure SQL database has issues, so I should take a look at it a bit more. See, I don't know. Anyway, there's performance issues, but part of it's the way it was written.
Well, you can have performance issues because you may need to maybe change the tier for something bigger, depending on the workload. I mean, those kind of things. If you choose a tier for your Azure SQL database, it's going to stay there. So you're going to see the resource usage maybe at the roof, and that's giving you the indication that maybe you have to upgrade or scale to a bigger tier.
Yeah, for sure. We've scaled it once at least already. Microsoft keeps doing things in the background that interrupt availability too. That's like it's a separate issue. It's that database though. So they keep moving it around and then saying, well, that's just normal maintenance. like in the middle of the day though. They just like switch it to
you
some.
can now they are working on giving you the possibility of setting up your maintenance window. You can specify the timing where they are allowed to, let's say,
Yeah.
play in background.
Yeah, we had it set from 5 p.m. to like 6 or something the next every day, and then the support said to us, no, change that so that it's the whole weekend instead. But I was like, but you had like 15 hours every day to do stuff. They're like, no, it's better we have the whole weekend. So I'm like, okay, well, fine. So I changed it, or my boss did actually.
Hopefully they will help allow us in the short future to have our custom maintenance window. That's gonna be nice.
Oh, yeah, that would be nice. I agree. Yeah, that'd be very nice. So does anybody have any, I didn't see, there was no other questions in the chat. Some people had to leave, but they said it was an excellent presentation. Patty Sullivan was here and Matt. So both of them said thank you. It was really great. And I loved it too. It was great. I learned stuff. I didn't use Querystore very much, so I thought it was great.
Well, in 2022, it's going to come up by default. So that's going to be nice, actually.
Yeah, unfortunately, I don't think we're going to get to use it because we have this cloud mandate where I am. We have to move everything into the cloud by the end of 2023. So we can't have, well, we could have VM in the cloud.
I mean, all in PASS services. I mean, you cannot use.
Yeah, pretty much. We have Azure SQL, we have Azure Postgres, we have, we don't have any managed instance, but we're moving mostly, now we have a mandate to move to AWS. So now we're looking at RDS pretty much exclusively. So maybe but maybe some of those 2022 features will wind their way up into these cloud offerings though, right?
Most probably, actually, you know, there are some of the features for the upcoming automatic intelligent query processing that they are already there, that you just don't know it. But if there are like trade flags that you can easily enable it and start playing around, because they are not GA yet, but you can enable it. For example, there is something called Querystore hints that, for example, is gonna, I mean, it's the same concept that we just saw now, but for, you know, more cases. For example, it's gonna capture everything, and eventually, you know, if there is a particular piece of code that may have better, you know, resource usage, less duration, etc., with a hint, right? Instead of you going, opening the store procedure and modifying and adding the hint, it will do it for you automatically.
Okay.
So,
okay.
That is the one that is already there. There are few others coming, you know, if you see some of the presentation. I mean, it's still not a lot of material available because, again, it's still in private preview. Soon, when it comes public preview, there's going to be a lot of presentation around it. But for example, you're going to have the possibility of, you know, again, with Querystore, and you will have DOP feedback. So if you run a piece of code and it detects that maybe with a different degree of parallelism, it's going to run better, right? It will set it for you automatically without you doing anything. Right?
Oh, nice. Okay, that's nice.
And also there is another one called CE feedback, right? Cardinal estimation feedback, that if it detects that what you are running could run better with a different version of the cardinal estimations, the legacy one, or you know, a specific version, is going to set it for you automatically. So again, the concept is the same. They're still adding more features to this toolbox to accomplish this main objective, which is, you know, have a stable performance all the time, right? And there are other different cases. So I believe is great. What I'm seeing in the private previews is really promising. So
yeah, that's good. That's excellent. Well, thank you so much for presenting. It was kind of short notice too, so I appreciate that. And it's getting late for you too, so I appreciate that as well. So it's very good. I learned a lot. I appreciate it.
Very good. Thank you again. Thank you for the invitation.